Hello, this is a video on chapter 5. So let's continue talking about probability distributions, but this time the probability distributions are continuous probability distributions. So in chapter 4 we talked about discrete probability distributions, and now we want to talk about continuous probability distributions. So let's start. So here we go. Let's start this section. So in chapter 4 we talked about probability distributions that were discrete. That means that so for example we had x was binomial and x could take values from 0, 1, 2 and all the way to n, right? And we could find probability of each of these numbers, and then we would have a distribution that we called probability binomial distribution. We also talked about geometric distribution, which basically x could take any values from 1, 2, all the way to infinity, and then we find probability of each value, and those would make a distribution, discrete distribution, and that was geometric. We also talked about Poisson. So x could be Poisson distribution, and for Poisson we just need a average. And so we had x could take values from 0, 1, 2 and all the way to infinity, and these had probabilities, and we could find probabilities, and that would make a probability distribution discrete. And we also kind of in the notes we mentioned hypergeometric, but we didn't really I didn't put it on test, but you can review it for yourself. All right, so in this chapter what we want to do is very similar, but this time think of if we have a situation where x can be any number, let's say from 2 to let's say 10. So this is x-axis, so this is x-axis here, this is number line x-axis. So it's kind of tricky now because we don't have finite number of numbers. You see, when we say x could be from 2 to 10, that means it could be any number from 2 to 10, not just 3, 4, 5, not just integers. So x can be 2.0001, it could be 2.1, 3, 2.9, right? Square root of, let's say 7, right? So any real number. Now, since we have infinite number of numbers, it becomes tricky to talk about probability of each of these numbers, because you see problem is that if I say, for example, what's the probability of number 3? Well, the probability of 3, well, 3 is one number, right? But how many numbers do we have? Infinite. So what's 1 divided by infinity? Well, that's 0. So probability of a single number is really 0. Can't have a single. So how do we deal with this? Well, here's how we can do it. We can think of let's say y-axis, just like in algebra, right? We have y-axis here, and then we're going to say, okay, what we can do is we can make a rectangle here, right? and then make sure the area of this rectangle is 1. Area of the rectangle is 1 unit. How can that be? Well, this right here is 8 units, right? From 2 to 10, 10 minus 2 is 8. Now we have to put a height over here so that when we multiply that height by this 8, we get 1. What times 8 is 1? Well, 1 over 8. So in this case, what we can do is this. We can say, okay, we think of trying to, let's say you're trying to hit this rectangle, right? Now the probability that you hit somewhere in the rectangle is 1. Let's say this rectangle is right in front of you. So you're standing here and you're hitting the rectangle with a ball or something. And the only thing in front of you is just this whole wall is the rectangle. So when you throw the ball at the wall, well, it's going to hit somewhere. So the probability that you're going to hit the rectangle is 100%. So we call that 1. So area of the rectangle is 1. So area of the rectangle is basically the sample space, is everything. But is not really the same in the same sense as the sample space that we had in chapter 4. So what we have here is area of the rectangle is 1. So now we can talk about what's the probability that I'm going to hit this area between 2 and 3. Well, the area is what proportion of the rectangle. So basically we have to divide this area by the whole rectangle to say what proportion of the rectangle that area is, right? So this area is what proportion of the whole rectangle? Well, that would be the probability to hit this part of the rectangle. Now, basically what we have to find is the area of this rectangle. And area of this rectangle is nothing but the distance here, which is 1, times what? The distance here, which is 1 over 8. So it would be 1 times 1 over 8. 1 times 1 over 8, which is 1 over 8, and that is the probability. So we can write it right here. We say probability that x is between, let's say, greater than 2 and less than 3 is equal to the distance from 3 to 2 times the height that we had right there. That's the height right there, right? All right, so this idea helps us think of this as a probability distribution where x can be any number. So x can be any number between 2 and 10, including 2 and 10. All right, so x can be any number between 2 and 10. And then the height right here, we're going to call this height f of x, which is like in algebra, f of x, right? So we're going to call it f of x. And f of x is going to be 1 divided by 10 minus 2, basically, which is 1 over 8 in this case. So now we can find any probability. So x is defined to be here. X is a distribution we call uniform. And the two numbers that we need are 2 and 10. So that's how we represent this distribution, which is a continuous probability distribution. So we can find probability of any interval of numbers. Probability of a number, single number, is always 0. But probability of an interval of number is whatever that area is. Now, some students get confused with this because, well, we say the height is the probability, and so every number has a probability of 1 over 8 then, just like in histogram we did in chapter 2. But this 1 over 8 is not probability, but is something we call PDF, probability density function. So what does that mean? It means is probability per unit of length. So 1 over 8 is the probability per unit of length, whatever the unit of length is here too. So if I want to find probability of x is between 2 and 3, let's say 2 and 5, let's make it 5 here. What if I want to find probability that x is between 2 and 5 here, right? So what I have to do is just do the distance between 5 and 2, which is what? 5 minus 2, and then multiply by 1 over 8. Now here 1 over 8, the unit for 1 over 8 is probability per unit of length, right? And then here what we have, 5 times 2, the unit of that is the unit of length, right? So that's 3 units. So the unit and the unit can cancel. So what we get is basically probability. So it would be 3 over 8, which is the probability. So that's the idea. So in this chapter, we're going to talk about 3 important probability distributions that are continuous probability distributions. And I'm going to talk about them. So here are the 3 probability distributions. We got the continuous, the uniform one we just talked about. And then we have the exponential, and we have the normal. So the trick here is to find a ceiling to cover the numbers such that the area under it is 1. Now with uniform, it's easy to do that. All you have to do is make sure that number is basically 1 divided whatever the length is here, right? And we get it. But we have other distributions when x is not limited to be just between 2 numbers. For example, with exponential, x can be greater than or equal to 0, any number. So x can be any number this way, all the way to infinity. And with normal distribution, x can actually be any number from negative infinity to infinity. Now, the difficulty is, how do we find ceiling such that when I put it over all the numbers all the way to infinity, the area under it is 1. And we don't have to worry about where this comes from. It was invented for that to do what we wanted to do, to make the area under it 1. And also this one, this is even trickier. So you need a ceiling that you put over all your numbers, and area under it is 1. That's, again, we don't care where it comes from, but I have a little few links here you can go to and see where these 2 came from, but that's what we're going to talk about in this chapter. So we're going to talk about these 3 different continuous probability distributions. So I'm going to let you read this part. This is just an introduction to it, and I'm going to go to again talk about the 3 different distributions that we're going to talk about in this chapter: uniform distribution, the exponential distribution, and normal distribution, which is actually chapter 6, right? So this one is actually in chapter 6. All right, so let's start with uniform distribution. That's what it looks like. Uniform distribution looks like this, and exponential looks like this, and normal looks like this. Again, let's get to every one of them one at a time. So let's talk about uniform distribution. So in uniform distribution, what we have is x goes between two numbers. We call them a and b. And the height of the distribution right here is always given by 1 divided the distance between a and b. The distance between a and b is b minus a, like that. Okay? So when you multiply 1 over b minus a by b minus a, you get 1. So the area under here, the whole thing here, under the rectangle, is always 1. Okay? All right. Now, so what we have now is notation for this distribution is given by this. So x is uniform with the parameters that we need are just a and b, the two numbers. That's all. A is the lowest value of x and b is the highest value of x. So how do we find probabilities under uniform distribution? If we want to find probability between c and d, so let's say this is c and this is d. So the probability between c and d, if x is between c and d, so probability of x values being between c and d. Now notice that equality here doesn't really matter, remember? Because the probability at a number is always 0. So it doesn't matter whether we put them or we put one of them or none of them or both of them, doesn't matter. These are actually the same. And that probability equals to f of x, which is basically whatever the height is here, and times the distance between c and d, which is d minus c. Now, there is every distribution, as we talked about before, you know, every distribution has mean and standard deviation. So the mean of this distribution is a plus b over 2, and the standard deviation is the square root of b minus a squared over 12. Now you might ask, where do these the formulas come from? They look weird. Well, they kind of do, and this is where they come from. They come from calculus. Now, why do we need calculus to find mean and standard deviation? Is because we can't do it with the formulas that we have. Remember, the formula that we have is what? Take all the x's and add them and divide by how many we have. Well, we can't do that because we have infinite number of numbers, and then we have infinite. What is that? What's infinity over infinity? It doesn't make sense. So that's why what we do to find the mean is using calculus. So instead of doing this, instead of using this formula, what we want to do is use calculus, which is like that. So what we do, we take each x and multiply it by f of x, and then we go from a to b and find out the area when you multiply that, and then we are going to end up with, in calculus we get that. So the trick here is to think of x as going from a number to a number, right? So that's the situation that we have here, and we have to find the mean of this distribution. And the mean of distribution would be every x multiplied by the height, and then remember we add them all up and divide by the number of numbers. That doesn't work because there are infinite number of them. So calculus can do that for us. So calculus finds that for us, and the answer is right here. The same is this for variance and standard deviation. We're not going to be able to use that the original formula we had. Remember, we had to take xi minus, mu, and then square it and multiply by frequency, right? And then divide by the total. Well, that doesn't work because we have infinite number of numbers. So we have to use calculus. Now, where these things comes from, you can read more about it yourself, but in this course, we are not interested in knowing how we can calculate mean and standard deviation. We just like to use them. So here are the formulas for the standard deviation and mean of a uniform distribution. We have two formulas. All right. So here's an example. The data that follow are the number of passengers on 35 different charter fishing boats. The sample mean is 7.9 and the sample standard deviation is 4.33. So if you put these numbers, these numbers in your L1 in the calculator and find the mean and standard deviation, that's what you're going to get, 7.9 and 4.3. Now, it says state the value of A and B. So it says the data follow a uniform distribution where all values between and including 0 and 14 are equally likely. So that means these numbers come from a distribution of numbers that are between what? Between 0 and 1. So you see, the x is between 0 and 14. So it could be any number from 0 all the way to 14, right? So x could be any number here. Now, what they did, they randomly picked numbers, integers, from the numbers from 0 to 14, and they got these numbers right here. So it says state the value of A and B, write the distribution in proper notation, and calculate the theoretical mean and standard deviation. Now, in theory, if the numbers are between 0 and 4, that is what? That's a uniform distribution. And in a uniform distribution, we know that in a uniform distribution, erase that. So in uniform distribution, we know that the mean and the standard deviations in theory have to be what? In theory have to be A plus B divided by 2, and the standard deviation has to be square root of B minus A squared over 12. So if these come from a uniform distribution, then in theory, these numbers, the 7.9, should be similar, kind of close to this number, and 4.3 should be close to this number. If it is, then we can say, yes, these came from a distribution from 0 to 4. Okay, so let's calculate those. So to calculate it, first of all, we put it in proper notation. And then the mu is 7, of course, because what? Because 0 plus 14 divided by 2 is 7. So that's in theory. But in practice, when you add these and divide by the number of numbers, which is 35, we get 7.9. But in theory, it's 7. And standard deviation, we just put the numbers in there, we get 4.04, which is what? Which is close to 4.33. Okay? All right. It says the distribution is given as that. What is probability of x being between 2 and 10? Find the 90th percentile. Now, first of all, right away, we know this distribution looks like numbers are from 0 to 20. So this is 20. And the height has to be 1 over 20 minus 0, which is 1 over 20. So it says find the probability that x is between 2 and 18. Well, that would be, let's say 2 is here and 18 is here, right? So what's that area? Well, that's easy. That's just what? That's 1 over 20 times what? That would be 1 over 20 times 18 minus 2, right? 2 to 18, 18 minus 2. So it's 1 over 20 times 16, so it's 16 over 20, which is about 0.8. So there's 80% chance that x is between what? X is between 2 and 18, right? That's the probability. Now, what about the second part of this? Well, the second part of this says that what is the 90th percentile? So let me erase this and then rewrite it, redraw it. So what I'm going to do, I'm going to draw again from 0 to 20, right? And now what we're looking for is a number right here, right? Right here, that this number where 90% of the area is to the left of this number right here, right? 90% of the area is to the left of that number. What is that number? Well, let's call it K. So the number would be, so this is 0 right here, so this is 0, and that's K. So we are finding what's the probability of x being between 0 and K. So the probability that x is greater than 0 and less than K is going to equal to, well, what is the height? The height is 1 over 20. So that would be 1 over 20 times K minus 0, right? Now, what is this probability? Well, we are told that this probability is 0.9 because we want to find 90th percentile, right? See that? So this is 0.9. 0.90, and then K minus 0 is just K. K times 1 over 20 is just K divided by 20. And if you give a denominator of 1 here and cross multiply, K equals to 20 times 0.9, which is 18. So that K right there has to be 18. So 18 is the 90th percentile of this distribution. That means 90% of the distribution is to the left of the number 18. All right? So that's the idea here. All right. So let's erase that. You can take a look at it one more time. Look at the calculations. All right, so now next we want to talk about exponential. So how does that work? Well, we kind of talked about this a little bit, but what this means is that we want to situate my microphone here. So what we want to do here is this. We want x to be any number greater than or equal to 0. That means we got x on the x-axis. X can be any number from 0 all the way to infinity. So what kind of ceiling do you put on the top here? Let's say this is y-axis. What kind of ceiling do you put on the top so that the area under it is 1? Well, we don't have to look for it because somebody has already figured it out. Is this f of x right here? And this f of x is given, you ready, by m times e to negative mx, where m is defined to be 1 over the mu of the distribution. So the mean of the distribution. And the mean of the distribution, we are either given the mean or we are given this number. Either given this number or the mean. Either way, we can find it. So, and this number right here is actually m. So we start with m, and it goes to 0 gradually all the way to infinity. Never crosses the x-axis. But here's something very interesting. This whole area is 1. All of this wide area, all the way to infinity, come back over here, all the way to this y-axis is 1 unit. So that's the exponential distribution we're going to talk about. And has a notation. The notation for it is that x is exponential, and the parameter for it is just that mu right there. Actually is m. They put the m there, not mu. So it's m. And then m is the same as, m is 1 over mu, or mu is 1 over m, the same thing. Okay, so let's talk about it. Now, exponential distribution is used in many applications. For example, the amount of time beginning now until an earthquake occurs has an exponential distribution. So if you want to wait and see, okay, what's the probability that I have to wait 10 years before there is an earthquake somewhere, that's exponential distribution. Another example would be the amount of money customers spend in one trip to the supermarket. So the amount of money that customers spend has a distribution that is exponential. So you start with a certain amount, which is the average. 1 over the average. This right here. We start for, so what's the probability that the customers spend 0? Well, it would be that. That's, that 0 is up there. That's the probability density function, not probability. And then we cannot find probability at 0, of course, because it's not defined. Remember, probability at a given number is always 0 under continuous probability distribution. So we can always talk about probability between a number and a number. So we say, what's the probability that customers spend like from this amount to this amount? Like from this amount to this amount. Then we can find this area. All right? So whenever we have fewer large values and more small values, right? Fewer large values and more small values, we get this kind of exponential distribution. All right? So very few people spend large amounts of money in a grocery store, and a lot of people spend a small amount of money. All right, so how does this work? Well, this is how it works. First of all, the notation is, as I said, it looks like that. The formula is this right here. It's basically the equation of this graph right there. So we can actually graphate the exponential distribution with the calculator and do all the calculations with calculator. So let's look at some examples. Again, we gotta have to have the mean, and we have to have a standard deviation for every distribution that we talk about. Well, the mean of this distribution is given. So if you're given the formula, if you're given m, then you're given mu, because they are related this way, right? And a good thing about this distribution is that these two are what? Are basically the same. So standard deviation of the exponential distribution is the same as what? As mu. Now we have two formulas to find the distribution, to find the areas. So if you have a distribution and we want to find the area, let's say from, let's say this is x, right? So we want to find the area to the right of x all the way to infinity. Well, this is, you have to use calculus to do this, but instead of calculus, we're going to use the formulas that come from calculus. And this is this formula right here. So probability that x is greater than some number all the way to infinity is given by this formula, e to negative mx. And the probability that, let's say we want a probability that x is less than this x here, all the way to 0, that area, well, that would be 1, this whole thing is 1 all the way to infinity, 1 minus this, right? So that's 1 minus e to negative mx, right? That's it. So, so you can learn this first and then use it to do that one, or you can learn this first and then use it to get this one, the same thing. So for x greater than x, the formula is that. For less than x, formula is that. So notice that we don't have a formula that says probability of x between two numbers, let's say c and d. So if we have such a thing, then we're going to have to kind of find the, so let's say we want to find the area from C to, let's say, D, right? Now how do we do that? Well, in that case, we're going to have to, let me erase that so I can work with that. So in this case, we're going to have to find the area to the left of D and find the area to the left of C and subtract them. And we have formulas to do that. All right, so let's do some examples. So here is, actually I can go to GeoGebra site and show you what it looks like. So with different values of m, we get different distributions, as you see. So this number is m right here, and the formula is given right here. You see 0.5 e to negative 0.5 x. So if m is 0.5, then the exponential distribution looks like this, and this is just area to the under it all the way to infinity, you see. So we can change that, and that changes. You see that? The shape of it, general shape of it, remains the same. So that's the distribution that we are talking about. All right, so let's do an example here. So in this example, it says that let x be the amount of time in minutes a postal clerk spends with his or her customer. The time is known to have an exponential distribution with the average amount of time equal to 4 minutes, right? So find the probability that x is between 4 and 5. So we can do this with formulas that we have. There are two different ways to do this. I'm going to do it both ways. So we don't have a direct formula. Remember, we have two formulas. One of them says probability that x is greater than x is given by e to negative mx, and probability that x is less than x is 1 minus that, right? Now, here, what we have to do, we have to find the probability that x is to the left of 5, and find the probability that x is to the left of 4, and subtract them, right? So that's the way we are supposed to do this. So Now, in this case, how do we write the formula for the distribution? Well, what are we given? Well, we're given, it says, the time is known to have an exponential distribution with the average amount of time equal to 4. Now, when we say average, we mean mu. So mu equals to 4, right? So mu equals to 4, so m is 1 over mu, which is 0.25. Once we know m, we know the distribution. So f of x is 0.25 e to negative 0.25x. Now, in case you're wondering what this e number is, I'm sure you kind of heard of it before. E is a number that is either right there, right here, and if you put second e and press enter, you see what it is. It's like 2.718. We also have e right here on the calculator. You see, it says e to x power. So if you pick that, then the calculator already has e, which is the same number, and it already has the to the raise to a power. You just have to put the power there, right? For example, if I want to calculate this when x is 5, right? So if I want to do this, just this part, when x is 5, so I'm going to put e to negative 0.25 times what? Times 5. So that would be that number. That's how we calculate. Okay? So that's not what we want to do, of course. What we want to do is what? Is to do probability of x less than x, so less than 5. So how do we do that? We have to use this formula. So the probability that, so let's put it here. Put it here. So probability, oops, let me get my pen back. All right. So the probability that x is less than 5 is going to be 1 minus e to negative 0.25 times what? Times 5. And probability that x is less than 4 is going to be 1 minus e to negative again 0.25 times 4, right? So now we can do it. So probability that x is less than 5 is going to be 1 minus, I'm going to go get this e thingy, put negative 0.25 times what? Times 5, there, that. So that's this probability. Then I want to take this probability and subtract it from this, right? So let me find it just separately. I'm just going to find that. So it would be 1 minus, again, e to the power of negative 0.25 times 4 this time. And that's that, right? So now why do we have to do this? Well, it's because, let me where'd it go? There we go. Let me erase this right here. We don't need the formulas, we already got the formulas. So let's get the pen. And now, so what we want is the area starting from here goes this way. So this is 4 and this is 5. So we want to find the area to the left of 5 and find the area to the left of 4 and subtract them to get what? To get this. and we already kind of did, right? See that? So area to the left of 5 is this number right here, which is 0.7135, maybe 135, minus 0.6321. There. So our answer is 0.0814, right? So, and here is the answer is 0.0814, and that's the picture of it. Now, we could have done it this way. You see, I can just do calculus with the calculator easily. All I have to do is go to y equals to and put the function in there, the PDF, the probability density function. So I'm going to put 0.25 and then go get the e to something and negative 0.25x, right? That's the function. Then I'm going to graph it with the calculator. To graph it is very easy. Just go to make sure all the plots are off, so you don't have plots. See, make sure your plots are off. They're all three should be off. So you go to y equals to, put that function in there. We go to window. Now, what's a good window to graph it? Well, we want to go from 0, and now the x max, this is 4, 5, maybe 7 is good. 7 is good. And the scale is fine, 1. Now y mean, of course, is 0, right? And the y max, we don't want to be bigger than that, much bigger than that. That's just 0.25, right? That's our m. So basically for y max, I put a little bit more than 0.25, maybe, 0.4 is good. And then graph. As you see, that's the exponential function right there. Now, the trick to find the area from 4 to 5 is to go to, once you're on graph, you go to that calculate, second calculate, and you see this symbol right here. This kind of, it looks like an S, number 7. S is for sum. So basically what it does, if you pick that and give it two numbers, 4 and 5, then it's going to go to the graph and find the area from 4 to 5. So let's do that. Let's pick number 7. So again, you have to be on the graph. Then you go to second calculate, number 7. So the lower one that we want is 4. So we press 4 and enter. And the upper one, we want it to be 5 and enter. And that's it. See? Finds the area and finds the number for you. And that's the same number that we found, right? If you do it by this formula, you see, it's the same number. So there are two different ways to do this, whichever works for you. If you only have x less than something or greater than something, the formulas are the easier way to do it. But maybe you find the method I just used easier, if you like to use it. All right, so let's do another example. The amount of time spouses shop for anniversary cards can be modeled by an exponential distribution with an average amount of time equal to 8 minutes. Write the distribution, state the probability density function, and graph the distribution. Okay? Well, so again, what's the distribution? Well, distribution is going to be exponential, right? And what is m here? Well, let's see. The average amount is what is 8, so that's 1 over 8. So our distribution f of x is 1 over 8 e to negative 1 over 8x. Don't forget to put these in parentheses. And that's it. Now, it says write the distribution, state the probability density function, and graph the distribution. We did all that already, right? Now 1 over 8, of course, is what? is 0.125, right? And that's how we state the distribution, right? So to state the distribution, we have to do x is exponential, and what is our m? 0.125. All right. A customer service representative must spend different amounts of time with each customer to resolve various concerns. The amount of time spent with each customer can be modeled by the following distribution. Find the 70th percentile. All right, so let's see. So we have the graph is a distribution that is exponential, and we know what m is 0.2. Why? Because it's given right here. So the f of x here is nothing but 0.2 e to negative 0.2x, right? All right, now, so what do we want to find is the 70th percentile. That means we need a number here such that there is 70% of the area to the left of it. Now, first of all, we know the formula to find the area to the left of a number under exponential. Remember, probability that x is less than x is what? Is 1 minus e to negative mx. So probability that x is less than k is going to be 1 minus e to negative mk. Now, what is m in this problem? Or why put m if you know what it is, right? So it is 0.2 and then k, right? 0.2 k, because x is k, right? Okay, now, what is this probability supposed to be? It's supposed to be 0.7 or 70. 1 minus e to negative 0.2k. Now, a little algebra. If you have e to something equal to a number, to get this x downstairs, we have to take ln of both sides. Now, ln is logarithm. You just have to know that if you take ln of this side and take ln of that side, ln and e cancel each other, you just get x by itself. You get x, and then the answer would be ln of whatever that number is. So ln and e are inverse operations. You just, with the calculator, there is ln, you can find it. You don't have to worry about how to solve this equation, you know, where this comes from and all that. That's from pre-cal, we don't need that. I'm from algebra. So all we need to do is we have to isolate this part. So to isolate it, I'm going to take this, which has a minus here, right? I'm going to move it to the left hand side, and I'm going to move that to the left side. So I'm going to get e to negative 0.2k equals to 1 minus 0.7, right? So I guess we can delete that now. All right. So if what is this? This is just e to negative 0.2k equals to 0.3. So if you take ln of both sides, I'm not even going to write ln on this side. I'm just going to write negative 0.2k, this is k, equals to ln 0.3, like that. So k is going to be, what is it going to be? It's going to be ln 0.3 divided by negative 0.2. And we know how to do this with the calculator. So here we go. So we're going to do what? I'm going to do clear everything. So we're going to do ln, that's ln, 0.3, parenthesis close, find it, and then divide the answer by negative 0.2. So 6.01. So this number right here has to be, so this number right here has to be 6.01 something, right? That's what that is. So that means 70% of the numbers here are less than what? 6.01. All right, so let me show you the answer, which is that right there. All right, so it is known that the waiting time for a patient in a doctor's office is exponentially distributed with an average wait time of 30 minutes. Given that it has already taken 31 minutes, what's the probability that the wait time will be more than an additional 35 minutes? So basically, the situation here is an exponential, right? And what is our m here? Well, it says that the waiting time, right here, it says an average of what? Wait time of 30 minutes right here. So the average is 30 minutes. That means this number is 1 over 30. So that means our f of x is 1 over 30 e to negative 1 over 30 x, right? So that's the distribution. Now, the question is, given that it has already taken 31 minutes, what's the probability that the wait time will be more than an additional 35 minutes, right? So the exponential distribution doesn't have memory. So whenever you enter a building, right, you start this time, right? Then the waiting time is exponentially distributed. Now, if you have waited, 31 minutes already, it doesn't matter. Even after you waited 31 minutes, the rest of this is still exponential. It's the same formula to find the areas. It doesn't matter how long you've been waiting. You could go way over here and wait like at 100 minutes. What is the probability? How do you find probabilities if you have waited 100 minutes already? It doesn't matter. It still would be the same formula. So that means in this case, the probability, let me erase that. So the probability that x is greater than 66 minutes, because if you have waited 31 minutes, 35 more, that would be 66, right? So the probability that you have waited greater than 66 minutes, given that x is already greater than 31, then is the same as probability that you have to wait basically 35 minutes more. So that 31 minutes doesn't really count. So if you say, what's the probability that I'm going to wait an additional 35 minutes? So I've waited 31, 35 more, that's 66. So what's the probability that I'm going to wait 66 minutes given that I've waited 31 minutes? Well, it's the same as if you started from now and you waited 35 minutes. The same. And we know the formula for that. Probability that x is greater than x is e to negative mx. And in this case, m is 1 over 30. So we put this in the calculator and we get about 30%. Okay? All right, so that's exponential distribution. One more few more of these, you see. The figure below shows the probability density function for the random variable x. The shaded area represents probability that x is between 4 and 7. What's the probability that x is between 4 and 7? Well, this is a continuous probability distribution, and remember we said that in order to do continuous distribution you have to have a ceiling, right? If the ceiling is straight like that, we're going to get uniform distribution. If the ceiling is like that, we get exponential, right? If the ceiling is like this, we get the normal distribution, which is we're not going to talk about in this chapter. We're going to talk about in next chapter, chapter 6. All right, so in this case, this is a probability distribution, continuous probability distribution, but it's not a celebrity, it's not a famous, it's just somebody made it up. See, they put a kind of a slanted ceiling here, and the numbers go from 2 to 7. So this distance right here is 5. Now, what should the height be so that the area of this whole thing, see, the area of this whole thing under the ceiling has to be what? Has to be 1. And that height is actually 0.3. If you use geometry and find the area of this whole thing, you would get 1. Now we know this whole area is 1, so probability that x is between 4 and 7 would be this area. Well, this area is actually a rectangle and a triangle, so we can find them and add them. What's the area of this rectangle? Well, this side is 7 minus 4, which is 3, and the height is 0.1. So 3 times 0.1 is 0.3. And this triangle, the base of it is what? Is again 3, and is 3. And the height of it is this distance from here to here, which is what? Which is 0.12, right? 0.12. So 0.12 times 3 is 0.36. So 0.3 plus 0.36 is what this area is. And I'm gonna 0.3, I'm sorry, I didn't divide it by 2. 0.36 divided by 2, because it's a triangle, right? You multiply, what's the area of a triangle? 1/2 base times the height. So I multiplied base times height, but I didn't divide by 2. So divide by 2, 0.36 divided by 2 is 0.18. So 0.18 plus 0.3 is 0.48. So that's the answer. Almost got it wrong, right? I actually did. But that's okay, we corrected ourselves. Alright, if x is a continuous random variable with the uniform distribution, right, what is probability that x is less than 5 given that x is less than 11? Now in this case, if we consider x to be from 4 to 18, then that would be a uniform distribution. We can find any kind of probability we are given, and the height would be 1 over, what's 18 minus 4? 14. Okay, that would be, if we wanted to find probability without the conditional, just for example, probability that x is between 4 and let's say 11, we could just use this, right? This is 11, and we can find the area right here, right? But that's not what we are given. We are supposed to find this actually, so that's the question. How do we do that? Well, to do that, you have to consider that condition. So the condition tells us that x is not really from 4 to 18, but is from 4 what? From 4 to 11. So I have to go to 11 and then put a height here that makes this area 1, because I don't care about the rest of the rectangle. I'm caring about just this rectangle. So if I'm dealing with this rectangle, what's the probability that x is less than 5? What's that? Well, the height is not 1 over 14 anymore, is 1 over what? 11 minus 4, which is 7. So the probability that x is less than 5, given that x is less than 11, is basically 1 over 7 times what? 5 minus 4, which is 1 over 7. Okay, so that's the, you can look at it one more time if you like, by stopping the video and going over it, but here's the answer for this problem. Okay. Alright, so there are some problems again from chapter 5, review for the final exam. You can look at it. If you have questions, just let me know. Alright, so I'm going to end this video now, and then next time, remember, next video, we're going to talk about what? We're going to talk about a situation when x can be what? Any number from negative infinity to infinity. And we're going to see one of the most important graphs in the history of mathematics, and that's what? That is the normal distribution. So I'm going to end this here, and I'm going to see you one more time. Hello. Let's see. All right. So I'm going to see you in the next video. Take care of yourself and others, and I'm going to see you in the next video. Take care.